So what did we learn today? Just reviewed physics basically, but here we have centripetal force. An object moving in a circle always has the momentum moving outwards, right? You can see that this velocity is always going outwards, tangential to the circle, and then acceleration is going in towards the circle. Velocity is constantly changing in direction, and then we have these two, a period and a frequency. Right, a period is basically the inverse of a frequency, or a frequency the inverse of a period. So a period is time per cycle, seconds per cycle, measured in seconds, and a frequency is cycle per time, measured in hertz. Okay, next we are on to centripetal force. Centripetal force, it involves, well, basically it just goes where acceleration goes, because F equals ma, right? F equals ma, and just acceleration goes inwards, so force also goes inwards, depends on the mass. But yeah, centripetal force is equal to net force in, does it? I don't know. Anyways, let's move on to vertical circular motion, right? So vertical circular motion is, there's a few parts. There's a FG, and there's a force applied. Force applied can either be, if you're spinning, let's say you're spinning something on a rope, that would be force tension. If you spin something on like a roller coaster is doing a loop-de-loop, that would be force normal. It can be a few different things. So in this diagram here, we have, I don't know if you can see, but we have force normal. Okay, let's draw something. We have at the top, let's say it's a roller coaster doing loop-de-loop, right? At the top we have force normal, and then we have force of gravity. So force normal is always against the surface, right? Or yeah, if the surface is here, it's going against the surface. And force gravity here. On the sides, it's just force normal coming in. Sides is force normal. On the top, it's, and acceleration is coming this way, so the centripetal force, net force, is inwards towards the circle. At the bottom, the F net, or the force normal, will be going upwards, and the force gravity will be going downwards. So these are counteracting. Yeah, I forgot what I was going to say. Next, we have minimum speed. So this depends on a few things. Well, this is a special case of the vertical circle. We have Fc equals F. This is where force, centripetal force, equals to gravitational force. So there is no force normal, because this is the minimum speed that you need to keep an object in, to keep the object up without it actually pressing up against the, it's not actually pressing against the rail, it's just there. Does that make sense? I don't know, but there's no Fn at the top, basically. Force normal at the top. Or if it was tension, if it was a rope, there would be no no force of tension. We have Kepler's 3 laws of planetary motion. Planets orbit the sun in an elliptical fashion. The sun at the center, then we have the planets in elliptical orbit. Second, planets will sweep out equal areas in equal time. Basically meaning that, like, for this piece of a pie, we'll say it takes an hour. That's not true, but it takes an hour to orbit this. This part, if it's the same area, these two are equal in area, it will take the same time, even though it might be a little bit bigger. So basically the planet travels faster at some point here in the law of periods. t1 squared over r1 cubed equals to t2 cubed over r2 cubed. I don't know what it means.